Hi viewers, we've got some really great news for you this week. We're launching the brand new SF000 microLiDAR. It's a truly remarkable product which breaks all the boundaries in terms of size and weight. And you know what? To celebrate, we're going to give 2 lucky followers a chance to win this exceptional sensor. So please join us at the webinar. Click on the link below. You need to register for the webinar and stand a chance to win this amazing product. All right, welcome to our viewers and our listeners. This is a special edition of Light Conversation. My name is Phillip Constantine, and we joined for some really good news today by James Portman.
Hi, Phil. Hi, everybody. Yeah, this is the most exciting time for us when we're launching a new product.
Oh, is this about a product launch? So I was wandering around engineering and passed by the production line. And I came up with just the most amazing little trinket here. And I thought, why not have a conversation around one of the very first units to come off the production line? We haven't spoken about this. It's brand new. And my intent with the conversation was to get inside the mind of the engineer, the mind of the inventor, and let's maybe get our heads around how we come up with a product like this and where we're going with this. So, James, this is the new little baby that's been born. Maybe just give us a brief little intro and tell us what we're calling her.
Well, that is the SF000. I think, like most inventions and inventors, there's probably a lot more emotional input into these products than just pure logic and clear thinking. Yes. So, interestingly enough, the 000 has to do with the gauge of model railway tracks. I think pre-1950, if I'm not mistaken, and it's a particularly small gauge track. It's become obsolete now, but when I was designing the product, I was thinking small. That was the driver. And like everything that we developed, it came about as a consequence of a customer request. And it's always an exciting experience, if I can put it that way, when a customer walks into your office and he says, I love this product that you've made. It's the smallest one in the world. Please, can you make it half the size? And that's how the SF000 project started. As far as the name is concerned, it does have some meaning. The 000 is the small size, but the SF is an important prefix as far as lightware is concerned. We use it as an abbreviation for small frame. And what it means is that it's not a completely enclosed IP-rated housing. Instead, it's been designed to be lighter and smaller by removing the external casing wherever possible. That having been said, the optics are sealed. So if you do build it inside an airframe, for example, you can have an externally IP-rated value for the entire frame.
Great, and that's a good intro. Thank you, James. I can just add from my last trip around the Europe and US, visiting some customers, we definitely recognized for, our very small external IP-rated units like the LW20, which are mounted typically external to, some of the airframes and on UGVs, robots as well. We're finding IoT applications as well, where these units are mounted externally. Part of the conversation that I was having with some customers at the time as well was, well, this is all very well, but if we start considering the aerodynamics of an airframe that's moving at high speed, maybe we want to think about taking your very small sensor and how can we make it smaller and even potentially embed the sensor within parts of the airframe? And the suggestion that the customer made they made a crazy suggestion, said, well, maybe I would even want to embed your LiDAR sensor within one of the struts in some of the gear. And, I remember coming back to you and, we were just brainstorming one night and said, well, would that be possible? If we looked at a fiber strut, how could we, rotor a slot within a strut, and potentially embed something absolutely tiny within the strut. And I remember you went away that night, and I don't think you slept, because you called me 5 o'clock the next morning and you said, yes, Eureka, I've got it. What part of that challenge appealed to you when the customer said, I'd want to embed this within a strut? And, your current units at, I think it's 13 grams or something. Can we even go smaller? Can we even go lighter, without sacrificing, having something that's professional, industry grade, not moving into the hobby sphere of product, which is not what lightware does. So how were you intrigued, and why did you choose to take the challenge head on and stay up all night and come up with a solution?
I think you're describing here perhaps the most important part of product development. You really have to listen to your customers and understand what they're saying. And, as an engineer, you're always hitting your head against limitations. The laws of physics define barriers for you. Mechanical constraints are always an issue. But if a customer says, we have to have something done in a particular way, you have to find a way around it. And if you listen to some of our previous podcasts where we were talking about optics, one of the critical things about making a high-performance LiDAR is you have to have large optics. And that's in two ways. Number one is the diameter of the lenses, and the other is the focal length of the lenses. Basically, longer focal length gives you better performance. So when somebody comes along and says, please, can you make something really small? The mathematics kicks in immediately, and you realize that you're going to sacrifice performance somewhere along the line if you make it smaller. Of course, over and above that is, can you even get parts small enough to put into a package that size? And can you design a small enough package? Of course, everything has to be custom made at that scale. There's not a lot of off-the-shelf lenses or housings or even connectors that you can buy that will be done at that scale. But the challenge for me was to say, notwithstanding the mathematical limitations, can you reduce critical dimensions? And the one that makes the difference if you ever want to build something into a wing strut is that the cross-sectional area has to basically fit within a circle, which means you can't make a device that's long on two axes, because then you've got this big matchbox-shaped thing, and that won't fit into a wing strut. It has to be quite small. And that meant running small focal length lenses, short focal length lenses. Now, short focal length lenses are not ideal from a beam pattern point of view. So what we had to do is we had to switch to aspherical lenses to correct for optical distortion that would come out of the laser beam, and also to improve the quality of the image picked up by the detector. Now, once you've committed to tooling up for those kind of optics, you then have to make sure that the product is manufacturable, because sometimes smaller is more expensive. It is certainly harder to put together. And we wanted to make sure that we didn't compromise in some other dimension commercially. In other words, ended up making something that was 10 times the price, for example. So by going through the customization loop and doing customized optics, customized plastics for the housings, customized method of holding it with its own separate bracket, and then miniaturizing everything, we were able to achieve what the customer was asking for. And that was the real intriguing part from a design point of view. It wasn't about, can you make a LiDAR? That's never a question anymore. Of course we can make a LiDAR. The question is, can we make the perfect LiDAR for your application? And that is the engineering challenge, because there can be no compromise on that. If the customer says it must fit into a wing strut, it must fit into a wing strut. You can't say, oh, well, it's 10% bigger, and it doesn't quite fit, because then you have nothing. Instead, it has to be the perfect fit. And so, clearly the optics was the prime driver. But of course, during this development cycle, we also learn a lot. We get to understand other problems and other areas of importance, which would, of course, become the foundation of the next generation to follow someday. At the moment, I don't have the next generation, but the idea is there. One of the issues, of course, is that the more you squeeze into a smaller area, the hotter the components are going to get. because there's not as much airflow over it and so on. So thermal management, electromagnetic shielding, all of those problems still have to be dealt with so that you've got a professional grade product here, not just a toy.
So, James, maybe if you can just have us know, we're talking about the fact that you've used a special kind of lens here, the aspherical lenses. Maybe that is a good topic for a follow-up conversation. But, the lenses, if one just looks at the product head on, they're definitely a lot smaller than what we have right now. What is the diameter of these lenses?
The optical aperture, in other words, the usable area on the lens, is around 10 millimeters on each side.
Okay.
In itself, we can still go smaller than that, but in terms of a comfortable package size, that actually worked to give the form factor that we needed. The critical thing is the focal length, though. The focal length is only 12 millimeters. So there's a very short, fat lens, as we call it, a very short F number. I have to look at weight as well, which means selections of the right materials, not forgetting that while you're doing this, you can't compromise on the optical qualities of the material either. So you can't randomly choose a lightweight material. You have to choose a material that, for example, is opaque at infrared wavelengths. And surprisingly, many materials are transparent at infrared wavelengths. I think perhaps what a lot of people don't realize when you're trying to design a product such as the SF000 is the number of different characteristics that you have to take into account. It's never a simple issue because not only are you attempting to achieve the customer's key specifications, but you're also trying to satisfy the production line. Can they manufacture this in high volume without increasing the cost? So you have to satisfy the commercial side of it as well, and not get stuck with exotic components that are very hard to get or very expensive. And cosmetically, it has to look like a professional product as well. So there's a lot of dimensions go into it.
Yeah, and durability as well. I mean, our products take a hammering in the field. I mean, we have customers who are into thousands and thousands of flying hours with the products, and have to endure pretty trying conditions. And the other factor, obviously, is eye safety. So we had a previous discussion when one has an aperture like this, and you pumping a laser beam down that aperture, you need a lot less power. And as the aperture decreases, you need more power to have the same effect. So how did you get around, because this product is, it is class 1M eye safe. How did you manage to achieve that with such a tiny aperture on the optics?
Yeah, so in the end, we did make a decision, which was that we were going to compromise on maximum operating range. Even though theoretically we could have gone to a 100-meter operating range and we ran tests at that, we decided it was too close to the limit as far as eye safety was concerned. And when you're manufacturing in high volume, you want to give yourself at least a 50% margin on eye safety. So we've called it a product with a suffix of a B at the end of it. The B suffix for us is a 50-meter class product, which means outdoors against a natural target, it'll measure 50 meters. It will, of course, do more than that under ideal conditions. But by limiting the range to 50 meters, we were able to stay well within the eye safety rating. And, since the use case of this product is often landing or terrain following when you're close to the ground, 50 meters is often enough for that. Unlike, let's say, a product like the SF20, where you can also do maximum height measurement to stay within FAA flight restrictions. In this particular case, we were interested in close to the ground operation, and 50 meters is really good for that kind of application.
Yeah, I must say, I did earlier in the week. I saw one of these units on a test jig, and it was being tested in bright sunlight in the middle of the day. And they were getting up to 75 meters just in the test. But, I know that it's not being marketed as that right now, but it's a pretty powerful unit, for something that, that is this size. I mean, that's pretty incredible. So kudos to the team.
Well, in fact, it's very important that you mention that kind of thing. This is part of the culture here at Lightware, where the quality and the performance of the products are absolutely key to the way that we do business. And we don't want to make products where at the very maximum it'll meet the specification. It's not like that. We would like it to be that when a customer buys a product, they are always excited about what the product will do in their application. It really works in the real world. And we, of course, test everything, in incredible detail just to make sure that we can achieve that. It's a fascinating business because in the end, the only thing that matters is generating a very happy customer. But in order to do that, you have to recognize that the customer experience is not the same as the engineering experience. And you have to keep in your mind all the time, what is the customer looking at? What does he see? What does he feel? How does the product perform? So when you look at a small product, you cannot make the assumption that the customer has an expectation of a poor performing product, because that's not true. In this day and age, smaller products are often very high performing. So if you look at some of the other performance characteristics of the SF000, you realize that it includes things like first return and last return capability, which means that it's able to operate in rainy conditions, for example, or through mist and dust. You realize it can run, hundreds of readings per second, which again is unusual for such a small product. You realize that the general accuracy is in the region of a few centimeters, which is also amazing for a product this size. So we have not compromised on the features and the capability of the product in any way, but just because we've made it smaller.
Yeah, great. Let's maybe talk about, and I like what you're saying about the focus on the problem that we're solving and, the customer perspective versus the engineering perspective. I always joke with the team here, there are very few people who wake up in the morning and say, oh, let's buy a LiDAR today. It's always around the customer has a specific problem they need to solve. There's a job that needs to be done. So you mentioned a couple of cases around problems that this product would solve. And let's maybe just talk through those a little bit. So the first one you mentioned was terrain following.
Sure. So there is a movement in the drone industry towards smaller and smaller airframes. And whilst you have a small airframe, that doesn't necessarily mean you're trying to have a simple mission. The mission may be quite complicated. For example, indoor search and rescue, or search and rescue through a forest, where a smaller airframe is more suited. But you don't want to compromise on your sensors just because you have a smaller airframe. So there is a lot of pressure to create high-performing sensors that you can squeeze into a small airframe. So typically, if you're flying down a corridor, one thing you want to do is fly at about 1.5 meters above ground level. The reason why you want to fly that height is because that's the height of a human head. So normally, there is a clear area about 1.5 meters above floor level. So you're above the chairs, you're above the tables, but you're below the ceiling and the light fixtures and so on. But how do you know you're that high above the ground?
Yes.
The only way you can know is to actually measure where the ground is. And this is where a small LiDAR like this comes into play. Especially in GPS-denied areas and areas where you don't know where the ground is exactly, being able to sense the environment around you is so important.
Yeah, I mean, just the specific use case on that, I do know that there's a customer who is in this environment of the coronavirus right now. Drones are being used for sanitation in hospitals, and there is no room for error when a drone is flying indoors and needs to keep a very, very specific height above ground. So I think that's that's a key example. Let's maybe talk about the other use case you mentioned around landing.
Yeah, so it seems like an obvious thing. You've got a drone, you launch it into the air, and you send it somewhere. It may be beyond line of sight, so you can't see the landing zone yourself. And you may be delivering something like a medical package. Certainly here in Africa, we get a lot of that kind of business going on. The problem is that whilst you may have a Google map of roughly what the altitude of the landing area is, and you may have your own barometric altitude or GPS altitude, you don't know for certain that that is the exact height of the ground when you land. So you can take a chance, meaning you can hover 10 meters above the ground and then just descend and then hope that you're going to hit the ground and not run into something, or you can know exactly. And this becomes particularly important if you're looking at disaster relief areas, because how do you know that a tree hasn't fallen over in that area? How do you know there isn't a crowd of people standing there? There is no map that will give you that information. you require a physical measurement. But because you're limited in terms of the range that you can fly your drone at, your battery life and battery power are critical. You can't afford to put enormous, powerful sensors and big, heavy, expensive devices. You need something small that gives you a quick yes or no answer. Am I clear to land? And that's more the use case. Add some intelligence to the drone so it doesn't keep crashing. That's the critical thing.
Yes. So we say here at Lightware, saving the world's machines one LiDAR at a time. And then the obvious use case is altitude, right? I know that many of our customers are using these as, either primary, secondary, supplementary altitude information. And at 50 meters plus, it's a very, very effective unit for that as well.
Yes, especially people doing survey work or magnetometer surveys, looking for minerals and so on. You have to fly closer to the ground than you would really like to, and you certainly can't rely on your Google Map to keep you out of the woods when things go wrong. So yes, the terrain following is becoming a very important commercial capability of people who are using drones because they make their money by flying close to the ground, which is unfortunate because in the end, a drone is much happier when it's 100 meters above ground level and not flying into anything. But there's no money there. Yeah. The money is when you get close to the ground. So being able to make sure that you don't fly straight into the ground, that's really important.
Right. And then, James, obviously these units can be used offline with an independent feed. The unit can either, stream the data or we have the capability to integrate, right, to many of the the autopilot systems. Has that been carried over in terms of the functionality to be able to, integrate to these systems? Maybe you can mention a couple and just talk to that.
Yes, integrating our products into airframes, particularly for drones or even for ground-based vehicles, is a very important part of what we do here at Lightware.
Yeah.
We have our own platform called Lightware Studio, which allows customers to interrogate a product, to put settings in, to see how the data is coming out, and to understand the performance of the product before they install it into their own system. Once they put it in their own system, then it has to be compatible with whatever is the flight controller or the navigation system that's on board. And we work very closely with the ArduPilot team to make sure that all our products are pretty much plug and play on the ArduPilot platform. We also provide a full suite of APIs for many different platforms, whether it's a ROS-based platform or a simple Raspberry Pi. The customers can download from our website the APIs for the products and easily integrate them into their own systems. And again, I think it's important to realize that just because you've got a small device, which is not that expensive, doesn't mean you should compromise on how easy it is to install it and how easy it is to use it. We don't expect everyone to be hotshot engineers and understand about the world of LiDAR. Quite the contrary. Customers have their own problems that they are focusing on, and they don't need to be experts in other fields. So if you've come to the conclusion that you want to make sure your drone doesn't crash, then when you buy a product like the SF000, you want to be able to plug it straight into your flight controller, simple configuration, and you're up and running. And this is what we endeavor to do with all our products.
Great. Well, James, thank you so much. Thank you for sharing your insights today. I really appreciate your time. This has been an initial look into this new little baby with a monster set of stats and capabilities behind the processor, behind the unit. We're really excited to be bringing this to market. This is the first look at this very, very, very tiny little unit. I'd like to just invite our listeners to please keep an eye on the YouTube channel, keep an eye on our website. We will be doing a formal unboxing. We'll be inviting a couple of the other engineers to talk through some of the technical aspects, some of the software aspects behind this, and really celebrate some of the key accomplishments that are being released for this new product, the SF000. Thank you so much.
Thanks, Phil. Thank you, everybody. Hope you enjoy the product.
Hi, viewers. We've got some really great news for you this week. We're launching the brand new SF000 microLiDAR. It's a truly remarkable product which breaks all the boundaries in terms of size and weight. And you know what? To celebrate, we're going to give 2 lucky followers a chance to win this exceptional sensor. So please join us at the webinar. Click on the link below. You need to register for the webinar and stand a chance to win this amazing product.